double integrals over general regions. Okay, but you guys be normal, be cool, okay?
Did you put in like the part where we yapped about the?
Yeah, it's raw, unedited.
Oh,
I think it adds nice flavor.
just yapping on Wikipedia.
It was good though. I think you're good at, like, you pulled up the article and you told us interesting stuff right away. Does that make sense?
Yeah.
You like honed in. Wikipedia did a good job. Okay, set up iterated integrals for both orders of integration and then evaluate whichever one's easier and explain why. So double integral over d of y dA, and d is bounded by y equals x minus 2. Am I doing the wrong one? Okay. Oh, they're waiting outside. You can let them wait. It's fine. In a few minutes. Okay. So first things first, let's graph the region. I forget, who asked for 19? Okay, Kimberly. Did you find the intersection and graph it?
Yeah.
Yeah, okay. So I'll solve for x equals y plus 2, and then let me substitute that into the other equation. Did you do it that way? I don't know. There's a couple. Okay. So y squared minus y minus 2 is 0. So then we get y minus 2 times y plus 1 is 0. So y equals 2 or negative 1. And then x is going to be y plus 2. So they're going to intersect at 4, 2, and 1, negative 1. Very good. So we've got a line, and then this is a parabola opening to the right. Yes? Okay. So they want us to set up both, and then we're just going to evaluate the one that's easier. That's good. X, Y. 1, 2, 3, 4. 1, 2. So they intersect right there. And then also at 1, negative 1, they intersect. Okay, so here's the line. That looks terrible. Hold on. Here's the line. Beautiful. And then the parabola is going to go through the origin. Hopefully you can just tell, right? It'll go through 0, 0. And then with these points, I think that should be enough. If you want to add a little more, you can, but that's good. Because already, hopefully you can identify, like, here's the region D. Yes?
Yes.
Okay, that's D. So let's set it up the harder way first. Harder way would be if we integrate with respect to x last. Because notice, there's always one function bounding the region on the right, the line, and one bounding it on the left. When that's the case, it's easier to integrate with respect to y last. Okay, so let's do the hard one first to get it over with. So now we're looking at what's bounding it on the top versus what's bounding it on the bottom. And notice here, the parabola's on the top and the parabola's on the bottom for all x's between 0 to 1, right? And then it switches after x equals 1. The parabola's on the top, and then who's on the bottom? The line. So we're going to have to split it into two different integrals, okay? So let's do the nasty order first. We're going to do dy dx, okay? So the limits for x are going to go from 0 to 1. And in that case, for y, you're going to look at top function minus bottom function. Well, this is the graph of x equals y squared. So if I solve for y, y is equal to plus or minus rad x, yes? Which one's on the top? The positive rad x. Which one's on the bottom? Negative rad x. So the limits for y are going to go from negative rad x to positive rad x. That's going to be the first integral. Plus, second integral, x is going to go from 1 to 4. And then y is going to go from, now, bounding on the top is, and on the bottom, the line. So let's go back. What's the line's equation?
X minus 2.
Okay, so this is going to go from x minus 2 to rad x. Good? Okay, so then let's actually write up the integral. We have double integral. So we'll go 0 to 1, negative rad x to rad x. What's the function we're integrating? Y. So just write it down for now. We're not going to do this one, though. This is the nastier one. y, and then it's dy dx, right? So these limits are for x. They have to go with the differential on the outside. Plus, and then the other one's going to go from
0 to 4.
1 to 4, yeah? Uh-huh. And then x minus 2 to rad x. You still have y dy dx. Okay, good? That's the first option. Now we're going to do the other option. Are you ready? So the other option here, let me copy the picture and then I'll erase what I've written in. So if we're going to bound it, there's a function on the right, function on the left, and this time we're going to go dx dy, right? So limits for y should be constant. The region is bounded between y equals -1 up until 2. So this is going to go -1 to 2. And x is bounded between, so when you draw your line, it's bounded on the left by the parabola and on the right by the line. So x equals y squared up until x equals, very good, Vincent, y plus 2. How are we on that part? Yeah? The outermost limits are constants. The other limits would only be constants if we were integrating over a rectangle. If it's not a rectangular region, all 4 limits shouldn't be constants. Okay? Good. And then we just need one integral for that one. See how nice? So then we have integral from -1 to 2, y squared to y plus 2, y dx dy. And then that's the one you evaluate. Do you need me to evaluate it? You're good. Okay, so just the setup.
Yes.
Okay, perfect. Does that make more sense? A little bit? Okay, so 19's done. Okay, let's move to 35. Yes? They asked for both. Yeah, it said set up iterated integrals for both orders of integration. So they wanted you to set up dy dx and dx dy. And then it said evaluate it using the easier order. So I would say the easier order is the one that requires only, no pictures of the, the easier order is the one that requires only one integral, I would say.
But like, why do we have two and one that's
Well, look at it geometrically, right? When you're integrating with respect to x last, that means the limits for x are constant. When you're integrating with respect to y, this has to be top function, bottom function. It's not consistent through the region. This is the function on the top, this is the function on the bottom.
have we left two or why? And then one and one.
Yes, yeah. So if it looked different, maybe you could just do one. But like if it went through this way, right? Yeah? Okay. Okay, 35. Find the volume of the given solid, the tetrahedron. Who needed this one? Okay. Tetrahedron enclosed by the coordinate planes. So what does that mean? Well, yeah, all of the xy plane, the xz plane, the yz plane. Yeah, the coordinate planes. And the other plane is 2x plus y plus z equals 4. So let's graph this plane. The solid is basically going to be in the first octant. Okay? The base is determined by some region in the xy plane over which this plane basically lives, right? So the base is in the xy plane. The height is given by this plane's equation. So the height is given by z equals 4 minus 2x minus y. So let's graph it so we get an idea what's going on. And we'll just graph in the first octant. Okay. So here's x, here's y, here's z. What's the x-intercept? Good. And then the y-intercept?
0, 4, 0.
Good. And z? Good. Okay. So here's the plane. Here's a piece of the plane. Just a piece of the plane. And then the tetrahedron is basically, here's the base in the xy plane. And then the coordinate planes also determine the rest of the sides. So this is a side, and then that's like the back part. And then the actual, this plane is one of the faces at an angle, okay? So what we're gonna do is integrate to find the volume. It's gonna be double integral over D, where D is that blue triangular region. That's the base. And then the height is given by the plane's equation, 4 minus 2x minus y. I'll put dA because we haven't committed to an order yet. I don't know if we're going to do dx dy or dy dx. So when you write dA, then you're leaving it open. Okay? So far, are we okay? Yeah. So now let me just draw the region D. Let's do a 2D graph. So 2D graph of D in the xy plane. The y-intercept was 4, right? And the x-intercept is 2. And I'll draw it exactly the same way. So hopefully you can visualize what's going on. Yes, here it is. This is D. Okay. And then what's the equation of this line here?
Y equals negative 2x.
Good. Y equals negative 2x plus 4. So I think the easiest way to describe this base region is top function, bottom function, right? So I would integrate with respect to y first and then integrate with respect to x last. So limits for x are constant. What would they be? 0 to 2. And then limits for y, if you just want to draw a little line through, right? It hits first at y equals 0. And then it hits second at plus 4. Perfect. So those are my limits for x and y. If you did it the other way around, it wouldn't be bad. You would just have fractions. Because you would have to solve x in terms of y, and I'd rather not. So, and it didn't force us to set up both orders. So then from here, I would write out, you have 0 to 2. Oh, heavens to Betsy. 0 to negative 2x plus 4. And then 4 minus 2x minus y. What's our order?
dy dx.
Perfect. Okay. You got it from here?
Yeah.
Okay.
Professor,
Yes.
can we assume it's going to be dy dx because the bounds is with x, not y?
The constant ones?
No, the function bounds.
The
Now it's
function.
like from 0 to negative 2x plus 4.
Oh, but we designed it that way. So I could have done it the other way. I could have said y goes from 0 to 4, and then x would go from 0 to the line, but then I'd have to solve for x. So it would be y minus 4 equals negative 2x.
Yeah, but then it would be dx dy though, right?
Yes.
Yeah.
So whichever ones are constant, those limits have to be on the outside. So since these are limits for x, they have to match. Those go on the outside. Because you won't get a constant for your answer if the outermost limits aren't constants. If they have variables in them, your answer will have a variable in it, right? And that's a problem. Yeah, Lucas.
So that tied into a question I had about some of the earlier ones. We don't need to do the
Yeah.
It's just a concept question. It was like, on like say problem 3, where with the line test,
Uh-huh.
both sides like x and y are
Uh-huh.
bounded in ways that are constant.
Yeah.
So then can you pick like which one you want to go from 0
Yeah.
to a variable?
Yeah.
And just like,
Yeah.
okay, oh, cool.
So a lot of the time you can switch, and sometimes you have to switch because you can't integrate it the way it was written. Remember the one we did at the end of the lecture yesterday?
Okay.
Good?
Yeah.
So like for this one, Mustafa, I would just have done it this way because I don't feel like solving this, right? Because then you get x. Let's just finish it because we got this far. X is negative 1/2 y plus 2. So that's what it would be.
Yeah, you don't want it to like, yeah.
I mean, do you want to put negative 1/2 y in if you could have negative 2x? I just feel like it'll be a cleaner to avoid the fractions. I would do that. Good though? Yeah. I mean, whichever way you set it up on the test, I don't care. Yeah, Kimberly.
If we have time on the test, can we do both ways and see?
And
if-
check?
and
Yeah.
check?
And then on some of them, I'll ask you to like set it up
Both.
in all the possible orders. Like when we do triple integrals, then there's 6 possible orders, right? Because you have dx, dy, dz, and you have all permutations of those 3. So there's 6 possible orders always. Mm-hmm. Okay. Let's go to 39 next. 39. Who needed 39? I forgot already. We're good? We don't need it? Oh, okay. Maybe I misheard. 45. Okay. 45 really put you through the ringer, huh? So
Oh,
find the volume. of the solid under the plane, oh, this is good, z equals 3, above the plane, z equals y, and then between the parabolic cylinders, y equals x squared and y equals 1 minus x squared. Okay, so z equals 3, plane, flat like this. Z equals y, another plane like this. Okay, and then they're telling you it's the solid that's basically between those two planes that lives between these two parabolic cylinders. So those two parabolic cylinders are going to define the base region. And then the height, z, that we integrate that function is going to be top function minus bottom function. So you're basically going to have double integral over d. Top function is 3, bottom function is y dA. So it's just up to us now to figure out what does d look like, how do we describe it, how do we bound it. Does that make sense so far? Okay. Now, this one's 45. Let me see how much I graphed. I just graphed the base region, okay? So let's just graph the base region. Let me first figure out where they intersect. So let's find and graph D. So let's set x squared equal to 1 minus x squared. So 2x squared is 1, x squared is a half, so x equals plus or minus 1 over rad 2. Now these are basically two parabolas, right? One's opening up and the other one is opening down. And then you see how z is missing. So they're not really parabolas because they're described to be parabolic cylinders. They're parabolas in the xy plane, but if you project them parallel to the z-axis, it looks like an infinite sheet of paper that somebody like kind of curled up. And then you take another one and slice it through, so your base is going to be interesting looking, kind of funky. Okay, so they're going to intersect at plus or minus 1 over rad 2. So here, we don't have to be too stressed out. This is shifted up 1 unit, and then it's also going to intersect the x-axis at plus or minus 1, right? Are you guys okay? And then the other parabola goes through 0, 0. And then it's going to intersect the other parabola at plus or minus 1 over rad 2, which is less than 1. We'll just say here's 1 over rad 2, and then here's negative 1 over rad 2. Because we said so. That's where it is. Good? So then here's the region D. So what looks like the easiest way to define D? Do we have a function on the top and bottom or right and left? Top and bottom. So that means we're going to integrate with respect to x last. Those are going to be our constant limits. So x limits should be from? Perfect. And then y, top function, bottom function. So we start where? X squared up until? Yeah, so always remember you could just draw the line through. Where it hits first is the lower limit. Where it hits second is the upper limit. Good? I hate that I drew those lines. I'm so sorry. I wish I shaded it with the highlighter. So I'm going to do it right now. Please forgive me. You can't draw it diagonally. You have to draw the pink line parallel to whatever axis you're trying to find the bounds for.
No, but you could just shade the lines there.
I just think it looks sloppy. I like the highlighter better to fill in. Doesn't it? Looks cleaner.
Yeah.
I know. I was just hating all of it. I wanted the highlighter back in my life. Okay. Are we ready? Are we okay? Yeah. Okay. So the volume, let's remind ourselves we're finding a volume, equals integral negative 1 over rad 2 to 1 over rad 2. The other limits are going to be?
X squared to negative x squared.
Good. I left it 1 minus x squared, but you do you. And then we have 3 minus y. What's the order of our? There you go. dy dx. You need me to keep going or no? You're good? Everyone's good? You can finish from here? Now, you have to be careful. Like, you can't just go from 0 to 2 and double it always, because you don't know that z is symmetric over the base region. Does that make sense? Okay.
What
So,
if we double?
No, I'm just saying other times in Calc, haven't you like doubled it and then gone from 0 to what? No? You weren't even thinking about that. I put a bad thought in your head, huh?
Yeah.
Okay, sorry. I shouldn't have even mentioned it. I'm sorry.
Professor,
Yeah.
when do you know when to draw the 3D graph instead of? 'Cause you
I'll
said-
tell you. I know. Did you try to do it for this
Yeah,
one?
I did, and I was like,
Oh, bless your heart.
I was
Yeah.
confused. I was like,
You can try, but it's very
I did it-
hard.
I did it right, but I was like,
I'm sure you did.
yeah.
Okay, so you're just gonna have like a flat plane and then a slanty plane, and then, yeah, it's very difficult, but good. I'll tell you on the test for sure. Do a 2D and a 3D, or just a 2D.
Will it help to do 3D? Like,
Not always, because sometimes it's so hard. And you know why you didn't need it for this one? Because they straight up told you under this, above this. So you could have figured out which was the top, which was the bottom without the 3D graph. If they weren't so clear, then you would need the picture. Yeah. What was your question, Ray?
Oh, sorry, so you get the 3 minus y because we know that one's above.
Yes. So sometimes they won't say it so specifically. So then you would have to draw the 3D graph to figure it out. Yeah, but just the base region's enough for this one. But on the test, I'll spell it out. I'll say, give me a 2D and a 3D, or just a 2D.
Okay, so for the base region, we can pick any side, right?
What do you mean?
Like,
If you integrated the other way, you would have to do 2 integrals.
okay.
So I wouldn't do it.
will it be one for the x squared and one for the other one, right?
Yeah, because you would do right minus left, and then you would have to switch it right here, when y is 1/2. So I wouldn't do that, you know? Okay, are we good? What's your guys' question? Why are you talking so much? No, don't talk, because you distract other people. They were looking at you being so noisy. Yeah, Alicia. 39? Okay, we're going back. Are you ready? Okay. 39. Find the volume of the bounded by the cylinder x squared plus y squared equals 1, and then the planes y equals z, x equals 0, z equals 0, and we're in the first octant. Okay, let me see. I didn't really draw a 3D picture. So we know what this cylinder looks like, right? It's opening up along z-axis. Okay. Oh, and we're only in the first octant, right? So just this piece here, kind of. Oh, that looks terrible. Okay, whatever. Yeah, it's like a wedge of it, right? So we have this cylinder in the first octant. The plane x equals 0 cuts it. Okay, so that's back there. And then z equals 0. So that's down there. And then y equals z cuts it. So then you're going to come through. Y equals z is here. And then you would project it parallel to the x-axis when you slice it. Like, yeah, because right? You have the cylinder and then you slice it.
We need a circle cake.
Yeah, I should have brought the cake over from the Persian market. Can you imagine, like, you have a quarter cylinder and then you slice it at an angle?
Is it like if you cut it like this?
Yes, but you only had a quarter of it to start with.
Oh, the outer edge would have the swoop. Okay.
Yeah.
For some reason, I thought like the cut and swoop.
No, the cut's not a swoop because the plane cuts it.
Yeah, yeah.
But if you look at it, like, it's
Then
gonna
it
be
would have
curved.
some
Yeah.
swoop, yeah.
Can you kind of see?
Like,
It's hard to draw. You don't need to draw the 3D one, but
it's
I
like
can
a
imagine it.
Mhm.
Yeah.
I'm bringing the cake next time.
Tomorrow?
Tomorrow. You guys want cake tomorrow?
Can you bring it on exam day for comfort?
No, you don't want to be eating cake while you take a test. You're going to be distracted.
Exam.
Let me see. If I have time tomorrow on my way over, I can grab it tomorrow. How many of you are there? Will you all have a piece of cake? Okay, I'll get a few of them because they're like this. I could probably cut it into like 8 to 10 pieces. I'll get like 4. Okay, let me see how we do. They're really good. All right. Anyways, Alicia, the base region. Can you imagine what it's going to be in the XY plane, based off of my disgusting picture? Quarter circle. If we can get there, we're good. Okay? So quarter circle. Sorry, it's so gross. here. Let me shade it with the same color so that you're like, oh yeah, there it is over there. Okay. So it's up to you. Really, it doesn't make a difference if you want to do dx, dy, or dy, dx. I think for comfort, usually if we do dy, dx, everyone feels a little bit better, usually. Okay. So limits for x, let's make those the constant ones. X is bounded between 0 to 1. And then y is bounded between
0 to 2.
0 and root 1 minus x squared.
Good, yay. So you have to solve for y, and we use the positive radical because we're,
We're in the first octave.
yeah, first quadrant, first octave. Perfect. Good, so that's it. So then the volume is going to be integral 0 to 1, 0 to rad 1 minus x squared. What's
Y.
the height given by?
Y.
Y.
is equal to z.
Very good. Wow, you guys, you got this. dy dx. Do you want me to keep going, Alicia? You're good? Okay. The square root goes away really nice, so don't worry.
I don't know how I got it.
Can you see it?
I can see it.
You can see it, even with my disgusting picture. Okay. Yeah, there's
I
good.
only do the quarter circle.
If you ever get
Yes,
confused, you can just break it down by like for volume, you're finding your length integral with integral and then height is
Yeah.
your z function.
Yeah,
So just find your z function.
yeah.
Okay.
But sometimes we'll do the order different.
Yeah, like
Yeah, Ben say.
For the homework, I just only drew out like the D's. Oh yeah, since we know it's this shape.
Yes.
we
I think the
said-
3D one's mostly optional right now. Later it'll get more complicated. You'll need the 3D one. But these, no. That's why my 3D one looks so bad. I didn't practice it. I'm sorry.
Because I only just did D, just like, oh yeah, we just.
Yeah, you're fine. You're fine. If you can tell what the height is going to be, then you're good.
Nice.
Are we okay?
Yeah.
Okay. That one was 39. And then I did 45 already, right?
yes.
Yes.
Okay. Then 47. You guys, these were even hard when I was first teaching it. Because I didn't learn this well.
So you're saying don't feel bad?
Don't feel bad. Nobody comes out of the womb doing double and triple integrals finding volume. It's only with a lot of practice that you get good at it. I had this professor, he would give the most, did I tell you, the most confusing lectures for Calc for this class. I didn't know what was going on, but he put the easiest questions on the test. 5 questions on the midterm, 5 questions on the final. The midterm was 50% of your grade, the final was 50% of your grade. It was stressful, but they were thankfully easy. I won't do that to you. Okay, sketch the solid whose volume is given by the iterated integral. So 0 to 1, 0 to 1 minus x. So that's the base region, right? And then this is the height, 1 minus x minus y dy dx. So immediately you're going to say, okay, z equals 1 minus x minus y is giving me the height of the solid. Hopefully you recognize that's the equation of a plane. So if you want to think of it as x plus y plus z equals 1, go for it. Then the other thing I'm going to need to draw the solid is the base region, right? What's the base look like? So I can see the limits for x are from
0 to 1. No, 0 to 1.
0 to 1, and the limits for y?
0 to 1.
Okay, so let's draw that by itself first, just so we get a handle on it, and then we'll put the 3D graph together, okay? If you feel really stellar and you want to go straight to the 3D, that's okay. I don't recommend just yet doing that. That sounds aggressive. 1, 1. 1 minus x is like this, yeah? So this is the base. This is D. So the plane lives above this base. So it's going to be another tetrahedron, right? No, you don't seem convinced, huh?
Wait, what do you mean by it's gonna be another teacher?
It's like a cube, like
Yeah.
sliced diagonal.
Slice, slice.
How did you see that?
Well, because it's a plane and a triangle base.
Oh, so you just
Because we did one earlier.
okay.
There's like only so many variations of problems we do in this class. Like after a while, you're like, oh, that old shape. Does that make sense? When you get to that point, it's very exciting. Because then it's it's like repetitive. And then you feel good.
I wish it happened soon.
You wish it happened soon? It will. I mean, we're going to take a test next week, so. Haha. So here's the base. You just have to do so many problems. Probably do more than what I assign if you have time. Okay, and then the z-intercept, can you tell it's 1 also?
Yes.
And the x and the y-intercepts are also 1. So then this is hanging out up here. Here it is. Cute. Love it. I'll do diagonal lines like Roy suggested. Do you like this better? Looks good. So can you see the back xy plane 1, 2, xe plane, base 3, and then here's the slanty plane. That's the fourth base of it, basically.
But the only base we care about currently is the XY base.
Right. Because if we define the base to be that triangular region in the xy plane, then the height is given by z.
Could you flip and say like the base is XZ?
Yeah.
and the height
Yeah. Then you just solve for y. Oh no, we'll do it. He's not giving me ideas. We've done this.
is Y?
Calculus is old. Probably anything you think of, they've done it hundreds of years ago. So don't worry about that. Yes, you can change the base region to be anywhere. Well, anywhere that we have in our, any one of the coordinate planes. Okay, good. That one wasn't bad, right? 47's done. Okay, 65, last one. Evaluate the integral, ooh, so fun, by reversing the order of, I love these ones. Expect one on the exam. Yes, it's happening. Arc sine of y, pi over 2, cosine of x, rad 1 plus cosine squared x, dx, dy. So at least they were oh my, what was that?
Something crashed.
Something crashed?
It sounded like it.
Fireworks?
Oh, no.
I mean, it's almost 4th of July. People have them.
Oh, my neighbors do that. They'll blow them off before and
there's smoke
after.
right there.
Really?
Yeah, right there.
Oh.
Oh, God. Something
It's coming from behind the building.
Are we safe?
Oh, yeah. Oh, it's not.
Yeah.
That's the fire alarm.
Okay, just be ready. There was one year when I was teaching here, and the fire alarm went off like 3 times in the fall, but someone was pulling it.
Did they do it during final season?
They did it during one of my exams, and so then I had to redo the whole test because it was compromised.
And then you made the test one.
No, but I said if for some reason like this test gets interrupted, because I'm like, whoever paid someone to pull the fire alarm, if it happens again, I'm just grading wherever you stop. That's it. We're not doing a redo.
One of my friends at UCI had that happen.
Yeah.
The professor did that 'cause
Yeah.
they were too tired. Every
Well,
final-
it kept happening.
every
Yeah.
final season, someone
Yeah.
did that.
I'm like, wherever we end, that's your grade. After I rewrote the whole test, had to junk the first one.
Sounds awful.
It was. But somehow the fire alarm didn't go off once I said that. Okay,
That's so funny.
let's draw the base region. So y goes from 0 to 1. X goes from arc sine of y to pi over 2. Okay, so y goes from 0 to 1. X goes from arc sine of y to pi over 2. We know they intersect here, yes. If you want to think of it, this is the same as y equals sine of x, right? And that graph is concave down. Good. That was very good, Roy. X is bounded by arc sine on the left and pi over 2 on the right. So where do I shade?
The upper part.
Below the graph, yeah. So this is always where it gets tricky. So look at the order. Look at the order. So this has to bound the region on the left. This has to bound it on the right. So if you draw a line through, right, left, right, it has to be below the graph. Good? Okay. Now we're going to switch the order of integration. So I would want the limits for x to be constant. So the limits for x should go from
0 to pi
0 to pi over
over 2.
2. And then the limits for y,
0 to sine
0 to
x.
sine x. Nice. Are we okay? And then that's all that changes. The integrand remains the same. So you're going to go 0 to pi over 2, 0 to sine x, cosine x, square root, oh, that was ugly, 1 plus cosine squared x dy dx. And then from there, you guys should be good. Or who asked for 65? Do you want me to finish?
No, I just wanted to see how
The
it was
setup.
set up.
Yeah, the hardest part is you have to graph the region and then switch the limits. Yeah. And then from there, you're just gonna pick up a y, so you're gonna pick up a sine x, and then it's just a cute, relaxing u sub. Just let u be everything underneath the radical. And then you should get 1/3 2 rad 2 minus 1. This is lovely. Yes. I'm gonna remember it. Okay, Kimberly.
Could you have solved the initial double integral? Like how it was.
How would you integrate with respect to x? No, I'm asking you seriously. I can't see how.
Okay. Well, I mean, I guess if we were given just that problem with no other context, would we
I
have
know,
to switch?
yeah. I'll tell you, don't worry. That's so mean. If I were to just give it to you and not say anything and be like,
That
figure
was
it
what I
out.
meant to ask.
Oh, yeah. Would I change the directions and
Yeah.
withhold information? No.
Like, is this something
You
we
know,
need to
you know I want to see what you know. I don't write a test to trick you.
Well, we're like, oh, and inverse trig.
No. I'll tell you to switch it. Don't worry. Don't worry. I get no pleasure in stumping you. I just want to see what you know and what you studied, okay? But I want it to be like, if you didn't study, you can't do well. That's all. Okay? Good? That's a fun one. Practice it. Okay? Okay, good. All right, that concludes the lesson. Like and subscribe, and go to my, I've been recording, yeah. Calculus 3 video lectures playlist if you need more in-depth video lectures on these topics. Or follow me on Instagram and TikTok, Math with Professor V. Bye.